Welcome back to a little extra video on solving rational equations. A rational equation means it's an equation where there's an equal sign, which we have right here, but it entails having rational fractions. So fractions that have rational expressions in them, and our denominators have rational expressions in them. And so what we did at the beginning of the semester was we said if we have just fractions in an equation, we could multiply through by a common denominator so that we could eliminate the fractions. And that's what we're going to do here. But to do that, we have to factor each denominator to see what the factors are that we need to include. So the first fraction factors into x times x plus 2. We already have an x plus 2, and then we have an x minus 2. So the LCD that we're going to use for this is going to be an x from this first denominator, an x plus 2, and then an x minus 2. So that each of the denominators have factors that are in the LCD. So if we multiply through by the LCD of x times x plus 2 times x minus 2, what we're missing is the only thing that we really need to keep. And so we're missing in this first denominator the x minus 2. So that's what we're going to need. And then our denominators go away. In the second fraction, the x plus 2, we're missing an x and an x minus 2. So we have to multiply it by x and x minus 2. And then on the right-hand side of the equation, we have an x minus 2, so we're missing an x and an x plus 2. So x and x plus 2. Now we're going to multiply through and distribute. So we have x squared minus 2x plus 3x squared minus 6x equals 5x squared plus 10x. And now we're going to get everything to one side. So we have x squared plus 4x squared. So let's simplify the left first. So we have 4x squared, and then minus 2x and minus 6x is minus 8x equals 5x squared plus 10x. So I'm going to move everything to the right. So I'm going to subtract 4x squared, add 8x. So we'll have 0 on the left equals, you have to subtract 4x squared and add 8x here. So we have x squared plus 18x. And so to solve this, we are going to get 0 equals, and if we factor out an x, and then we have x plus 18, so either, we're going to take this up here, so either x can equal 0, x equals 0, or the x plus 18 equals 0. And so x could equal a negative 18. Now, we just have to go back up to our original denominators. Remember, we had up here, we had x squared plus 2x. Now, if we put a 0 in for x squared plus 2x, we're going to get a 0 denominator, which will create an undefined fraction here. So that answer cannot be used. So the only answer we can use is x equals a negative 18. Let's look at another one. So again, we're going to multiply through by an LCD that includes each fraction's denominators. So we have x squared, x squared, and x. So x squared should do it. So if we multiply each fraction by x squared, we can then cancel out our fractions, our denominators. So we're left with 1 plus X cancels with one of the x's here. So we're left with x plus x squared cancels. So we're left with 2 equals 1x cancels. This x cancels with 1x here with 3x. So we have x plus 3 equals 3x. Subtracting an x. We have 3 equals 2x. And dividing by 2, we have x is 3 halves. And one last one, just to make sure we're having the one that has a little bit more difficulty to it. And this one here, we have to find our LCD to multiply through. And that means we have to factor each denominator first. So this is 3 terms, so it's going to be 2 binomials if it factors, an x and x. We're looking for factors of a -12 that add to 1. So I can use, they have to be close together because they're just a difference of a +1. So I could use 4 and 3, and I want my bigger number to be positive for this 1 here on the x. So I'm going to use +4 and -3. Then my x squared -4 here in the middle is a difference of squares. So x plus 2, x minus 2. And then my last trinomial here, I need to have factors that multiply to make a -6. And the difference is a -1 this time. So the bigger one has to be negative. So we'll do a -3 and a +2. So it looks like the LCD is going to be an x plus 4, an x minus 3, an x plus 2, an x minus 2, and the x minus 3 has already been used, and the x plus 2 has already been used. So these 4 terms. So again, I'm only going to multiply through by the factors that I don't have it already included. So I have an x plus 4 and x minus 3. So I'm going to multiply through by the x plus 2, x minus 2. And then this middle fraction is missing the x plus 4, x minus 3. Then the last fraction is missing the x plus 4 and the x minus 2. Okay. So that's going to look like this. Okay. So before we do any distributing, I'm going to multiply the binomials together first. There's 3 sets of binomials. So this will still be 3 times. This was that difference of squares, the x squared minus 4. Subtracting 2. This x plus 4, x minus 3 was from the result of factoring this denominator up here, x squared plus x minus 12. So that's x squared plus x minus 12. And then this one we had not used before, and it's just a 1. So 1 times, we've got x squared plus 4x and a minus 2x. So that is a plus 2x minus 8. Now we can go ahead and distribute our 3 and our -2 and our 1. So we have 3x squared minus 12 minus 2x squared minus 2x plus 24 And then x squared plus 2x minus 8. And then, of course, we're going to add like terms. So I'm going to cross them out as I go. 3x squared and minus 2x squared leaves me with an x squared on the left. I have a minus 2x. And then a minus 12 and a positive 24 is a positive 12. Okay. And then we have on the right, we have x squared plus 2x minus 8. So we need to get everything to one side. So when we do that, the x squares will cancel out. And I'm going to move my 2x over here. So those cancel. So we have a minus 4x, and then I'm going to subtract 12. Get our constants on the right. Then when we divide through by the negative 4, we get a positive 5. And we just have to make sure that a 5 is not going to cause any of our original denominators to result in an undefined fraction. So it should not affect any of these. So our solution should be x equals 5. Catch me back for some other help lessons.